Hello and welcome to 7.1 Fundamental Identities and Their Uses. So in this section we're going to be talking about all these different relationships we have and how we can substitute into an expression and simplify the expression. And that's really what this whole chapter is going to be about. It's very much about using the fact that cosecant is 1 over sine, using these relationships. So let's go ahead and talk about these first. A lot of these are repeats. We've seen them, just kind of restating them for us here. So cosecant is 1 over sine. It's reciprocal. Secant is 1 over cosine. Cotangent is 1 over tangent. Sine is 1 over cosecant. Cosine is 1 over secant. And tangent is 1 over cotangent. Quotient identities. Quotient meaning fraction. Tangent is sine over cosine. Cotangent is cosine over sine. We also have the cofunction identities. Cosine is sine of pi over 2 minus x, and sine of x is cosine of pi over 2 minus x. Cosecant is secant of pi over 2 minus x. Secant is cosecant of pi over 2 minus x. Cotangent is tangent of pi over 2 minus x, and tangent is cotangent of pi over 2 minus x. Period identities, when they start repeating themselves, if it's not shifted in some way or have some coefficient for x, sine of x plus 2 pi is sine x. Cosine of x plus 2 pi is cosine x. Cosecant of x plus 2 pi is cosecant x. Secant of x plus 2 pi is cosecant of x. So those are all 2 pi with the period. Tangent and cotangent are different. Tangent of x plus pi is tangent of x. And cotangent of x plus pi is cotangent of x. Even and odd identities. Sine of negative x is negative sine. Cosecant of negative x is negative cosecant x. Now cosine of negative x is cosine. And here's a typo. Secant of negative x is positive secant of x. That's an important correction to make. The point is that cosine and secant are even functions. These are even. Whereas sine, cosecant are odd. Tangent of negative x is negative tangent of x, and cotangent of negative x is negative cotangent x. These are also odd functions. We also have the Pythagorean identities. Sine squared x plus cosine squared x is 1, and tangent squared x plus 1 is secant squared x. 1 plus cotangent squared x is cosecant squared x. If you will allow me for a moment, how do we get to this tangent squared x plus 1 is secant squared x? Well, if you divided all these parts by cosine squared x, sine squared x over cosine squared x is the tangent squared x. Cosine squared x over cosine squared x is 1, and 1 over cosine squared x is secant squared x. So that's where this one is derived. If you divide every term in the original by sine squared x, sine squared x over sine squared x is 1. Cosine squared x over sine squared x is cotangent squared x. And 1 over sine squared x is cosecant squared x. Okay, so it's not out of thin air. Those actually are derived. So we're going to use the above, all those identities we've just discussed, all of them, to simplify trigonometric expressions and to solve trigonometric equations. Let's start with the first one we have here. Use the trigonometric identities to simplify the expression. We have 1 over tangent squared theta plus 1. Now theta is just the variable there. And that looks familiar. If I look back up here on the screen, I have tangent squared x plus 1 is secant squared x. So that means I can substitute, say 1 over secant squared theta. I'm sticking with theta because theta is my variable. Well, what's 1 over secant squared theta? As you saw on the previous page, that is cosine squared theta. And that's it. Now we're going to use the trigonometric identities to simplify this expression. sine t times the quantity cosecant t minus sine t. What's that going to be? Well, this is sine t times cosecant t minus sine t times sine t. So I've distributed sine t across the cosecant t minus sine t. Now, sine t times cosecant t, if it helps to see this, this is sine t times 1 over sine t, that's cosecant t, minus sine squared t, because you have sine t times sine t. Now, sine t divided by sine t, this part just going to be 1. Something divided by itself is 1. 1 minus sine squared t. Now, we have the relationship that sine squared t plus cosine squared t equals 1. That's a Pythagorean identity. If I subtracted sine squared t from both sides, I'd have cosine squared t equals 1 minus sine squared t. So we can conclude that this is cosine squared t. And that's it. Okay, feel free to pause if you want to take a little more time writing this down. Now we have guidelines for viewing trigonometric identities. Let me clear the board here. Couple typos here. One is work, not word. Word. Okay. Number 1, work with one side at a time. Choose one side of the equation to work with and simplify it. The more complicated side is usually the best choice. You don't want to take a simple thing and try to make it complicated. Take the complicated thing and make it simple. The goal is to transform one side into the other side. Apply trigonometric identities as appropriate. To do so, it will probably be necessary to combine fractions. I know we don't like fractions. Add or subtract terms, factor expressions, or use other algebraic manipulations. And it is really important to remember your algebra. It's really important to remember things like a plus b squared is a squared plus 2ab plus b squared. Really important. It's also important to know that a minus b squared is a squared minus 2ab plus b squared. These are algebra things that are often forgotten by students. Also remember that a squared minus b squared is a minus b times a plus b. So all important things to know. Rewrite in terms of sine and cosine if necessary. If you're stuck, expressing, not expression, expressing, ing, expressing everything in terms of sine and cosine often leads to inspiration. You can start to see things if you see it in terms of sine and cosine. Okay, let's verify this following identity. We want to make sure it works. I mean, is this true or not true? Cosecant x minus sine x equals cosine x times cotangent x. So cosecant x minus sine x. Now cosecant x is 1 over sine x. So what we have is 1 over sine x minus sine x. Let's combine these fractions. Multiply this by sine x over sine x, so we have a common denominator. So 1 over sine x minus sine squared x over 1, no, over sine x, excuse me. That's going to be 1 minus sine squared x over sine x. Now what was 1 minus sine squared x? We saw that in the previous example. That's cosine squared x over sine x. So that means we can take this cosine and split it. Cosine x times cosine x over sine x. Now notice, our goal is to make it say cosine x cotangent x. We have cosine x times cosine x over sine x. This part is your cotangent x. So you end up with cosine x times cotangent x. So that means the identity is true or valid. Let me do the next one here before I scroll. Verify the identity 3 plus cotangent squared alpha equals 2 plus cosecant squared alpha. Now if we subtract 2 from both sides, we'd have 1 plus cotangent squared alpha equals cosecant squared alpha. Now the interesting thing about that is the Pythagorean identity. That was the third version that we saw. So 1 plus cotangent squared alpha is cosecant squared alpha. Okay, verify the identity that cotangent of pi over 2 minus beta times cotangent of beta is 1. So the first thing to do is recall that tangent of, we saw tangent x was cotangent of pi over 2 minus x. We saw that. So we can conclude that cotangent of pi over 2 minus beta must be tangent of beta. So what we have then is that this cotangent of pi over 2 minus beta times cotangent of beta equals 1. That means that's going to be tangent of beta times cotangent of beta equals 1. Now if you weren't convinced that this relationship, we can go a couple of ways with this. I'm just going to go with the relationship that cotangent is 1 over tangent. Tangent beta times 1 over tangent beta is 1. So tangent beta over tangent beta is 1. Identity is valid. I'll make that thing go away at the bottom of the screen, but that's okay. Okay, next example. Use the suggested substitution to rewrite the given expression as a trigonometric expression. And this is actually, if you're going to go into calculus, you're going to be doing this in Calc 2. And it's one of the ways you deal with derivatives. So we have x squared plus 1, where x equals tangent theta. So we're going to put tangent theta in place of the x squared. So we'll have the square root of tangent theta squared plus 1. So that's going to be the square root of tangent squared theta plus 1. These mean the same thing. Well, that is, as we saw earlier by the Pythagorean identities, secant squared theta. And the square root of secant squared theta will just be secant theta. Okay. Our last one from this section. Use the suggested substitution again to rewrite the given expression as a trig expression. Okay. So what we have is x squared plus 25. And we're going to do the substitution. Tangent of theta is x over 5. Well, we have an x here, so we need to solve for x. X would be equal to 5 tangent theta. So the square root of 5 tangent theta squared plus 25 is what we have. I put this in place of the x. So we have the square root of 25 tangent squared theta plus 25. That's the square root of 25 times tangent squared theta plus 1, which is the square root of 25 times what? Tangent squared theta plus 1 is secant squared theta. So it's going to be 5 times secant theta. And that's it. That's it for 7.1. Well, please let me know if you have any questions.